Hi, this is Bob Wormsley from INSYDIUM, and in this constraints tutorial we're going to be using forces to create a dynamic particle simulation. We'll use some data mapping to add some variation, and we'll get it to interact with our scene objects. We can then take those particles and mesh them to create this dynamic fluid sim. So let's get started. Okay, so let's set up a basic mograph scene using constraints forces. So what we've got here, we've got a motext object. Let's change this to, say, XP for X-Particles, just for this example. And we'll change the font to rawline. We're going to go bold, align it in the middle. Height, I'm going to make it, I don't know, let's say 400 centimeters high. And we want a bit of depth, actually, because this will help us get a nice bit of particle interaction later on in the scene. So let's put this up to, say, 50 or even 80 deep. That's looking good. Let's put a bit of a fillet cap on. So let's go to the caps, and we'll go from the start, fillet cap, which gives us a bevel. Let's make it 3 steps and reduce that radius. I don't know, let's try 3. Yep, okay, so that's a nice smooth bevel. So that's on the front. Let's put one on the back as well. Fillet cap, 3 and 3. So now we have this nice motext XP. Okay, so this is what we're going to be, well, we're going to be emitting particles from it, and we want those particles to actually interact with this text object as well. So let's just go to the emitter tab, bring in an emitter, and in the object tab of the emitter, we'll change the emitter shape from the default rectangle to object, and drag in our mo text. We want to emit from the polygon area, so particles will be covered randomly over the whole surface of this object. And then we'll go to the emission tab. And what do we want? We want a shot, because we want the particles being fired out on the first frame. And let's say, I don't know, 500 particles. I don't want any speed. And I want, let's just have a look. So they're quite difficult to see. The particles are there. Let's change the display mode so we can see them. So we'll go to display, edit a display from dots to circles filled, and we'll spawn again. So there are our particles. Now you can see they kind of look like half spheres because they're intersecting with our geometry. So what we want to do is birth them so they're slightly offset from that surface. So let's go to the object tab, and we've got an offset origin. Let's just offset it by 1 centimeter. And now they've been born slightly offset from the surface. Good. Right, so we want a variation of radius values here. So let's go to the emitter, emission tab, and the radius, let's set it to 6 centimeters, but with 6 centimeters variation. So what that's saying is each particle will have a radius value of anywhere from between 6 minus 6 and 6 plus 6. So that'll be a radius of between 0 and 12. So let's have a look. There we go. So we've got varying radius values for these individual particles. Excellent. So that's what we've got. So now we want these to behave dynamically. If we press play, nothing happens. So we want them to have these constraint forces applied. So let's go to our constraint object, to forces, we'll activate it. Let's just see what happens by default. So we've got a bit of dynamic movement, but not much. Why not? Well, it's because our text is like 400 centimeters tall, but our attraction radius of our forces is only 20 centimeters. So let's just bring in a 20 centimeter sphere. Put that down to 20. This is how far each particle can search and attract other particles within this radius. So it's tiny. What we need is to up that up to probably 400. So let's change in the constraints. Let's go to the attraction and change the radius for the attraction up to 400. So now they should attract loads more. Okay, that's good. So they're attracting. But each particle can only attract up to 16 others. So let's up that limit to, say, 50, because we want a kind of a bigger group. Okay, so that's kind of looking better. Good, so that's working all right. But at the moment, the particles are kind of interacting with each other in a dynamic way because of our constraints, but they're ignoring this model, this motext. They're just flying through it. So let's make them collide with it. So we'll go to motext, tags, X-Particles tags, collider tag, and we'll take the bounce off and let's just give it a bit of friction. So now, yeah, so now they're kind of interacting with this text a little bit. They're not able just to fly through it. They're being kind of dragged. We haven't got the look we want yet, but we're getting closer to what we're after. All right, so let's go back to our constraints. So what else can we do? Well, at the moment, our repulsion radius is really tiny. Let's just increase that and see what happens. If we increase, you see it's pushing them apart a bit. So we want them to be pushed apart, but we also don't want them to be intersecting. Now, the repulsion is kind of trying to prevent them from intersecting these particles, because if they're coming within this radius of each other, it's pushing them out. But we can help it along a bit just by activating our particle collisions inside constraints. We've got the collisions tab, activate those particle collisions. There we go. So that's looking good. And if we go to the constraints, to the forces, now what I want to do is something a little bit different. Now, similarly, when I was going through what these individual settings do, I want this repulsion to affect the smaller particles more than the bigger ones. So we get kind of the smaller ones swarming around the outside of our blobs. So how do we do that? Well, we have to map this value. So the repulsion value, let's map to parameter. We're going to map it to the radius of the particle. Now remember, let's have a look in our emitter. What are our particles? They are anywhere from between 0 and 12 centimeters in radius. So let's put those values in. Minimum 0, maximum 12 centimeters. And what this graph is saying now is, if a particle has 0 radius, it has full repulsion, which is 1%. If it has a 12 centimeter radius, it has 0 repulsion. So now let's see. And if we increase this radius amount, you should see, and maybe increase the repulsion strength. There, we've pushed them out. So now the smaller particles are swarming around the outside of our blobs. And already it looks nice and dynamic, and we've got some interesting kind of organic looking movement. Let's just reduce that radius. We want them to be a bit tighter than that. And I'll pull that in a bit so it's only the small ones. All right, so that's, I think, starting to look quite organic and quite interesting. I like the look of that. So how can we get more control? One thing I want to do actually is, with this mode text object, its origin is, if I hit Alt-D, you see the origin of this mode text is here on the 0 world origin. And I actually want it to be kind of in this point in the middle, and this is going to help us with getting our particles to move around all sides of this. So I'm just going to move it back. So in the mode text, the depth is 80 centimeters. So I want to move it back -40 in the Z direction. There we go. So now the center of this is at the world origin, which is what I want. Let's hide that axis again. Okay, good. So that makes no difference at this point, but it'll help us later. So now what we want to do is we want to be able to direct where these particles are and move them across this surface. So to do that, we could use one of two things really. We could use an attractor modifier, but I prefer to use a cover modifier. I just prefer the way it works, and I prefer the options. So we're going to go to modifiers, motion modifiers, and we're going to pick XP cover. Okay, and the cover's saying, what's the target object? What do you want to aim these particles at? So we could do this with geometry, with a model, whatever you want. I'm going to use just a null object. Let's bring in a null. I'm going to rename it target. And I'm going to make it just a star. This is a visual thing so we can see it. Here it is, so we can see it. Okay, so let's go back to my cover options, and I'm going to drag in my target to the object. Now, I don't need to cover or fill a volume because it doesn't have a volume. It's just a null. It's just a point in space. So modifier type, it's not an object, so it doesn't need to be this. It can just be target, and it's going to aim to the center origin of that null. Excellent. I want it to, the target effect, I want it to attract the particles. and I'll just leave everything else as it is. Speed mode, I don't want to use particle speed because the particles don't have any of their own speed. I want to put gravity, and here's my gravity strength. I don't know, I'll put it at 10 for now and we'll see. So now what should happen is that the particles should get born. They have their own constraints, forces attracting and repulsing them to themselves, but then they're all getting dragged towards this modifier. And there we go. And if I move that target around now, we can start kind of art directing these particles moving in this interesting organic way around our text. I'm just going to go to my collider tag. I've got friction set to 25. I just reduce that a bit so they slip over it a bit more easily. So this is quite a nice effect as well. They're all getting attracted to my cover target, and they're kind of organically moving across this, which is quite nice. Okay. So now we've got various different things that we can do to change the control of how this works. In our cover modifier, if I put the acuteness of turn to 100, it means that they'll really closely and directly follow that null object. So they're going right to the center point of it straight away. If I go to the cover and reduce the acuteness of turn, they'll take a much more of an arc towards it, which gives a kind of a more organic feel, doesn't it? And they're kind of then circling around it and gradually getting to it. So that gives you a different type of feel, just adjusting the acuteness of turn in this modifier. So that's good. So what other options can we have? Well, what we could say in the cover modifier is we could say that only the large particles get attracted to it. But then because we've got our constraints on, which are attracting other particles to themselves, hopefully the smaller particles will then follow. So let's see if that works. We'll go to the cover modifier. We're going to do this with data mapping. So let's get a map. And what we want to do, we want to map this gravity strength to the size of particles. So if the particles are bigger, it's pulled more towards the attractor target, and if they're smaller, not so. So let's have a look. We go to mapping, add a map, and the parameter we want to map is the gravity strength. There it is, gravity strength. And let's map it to the radius of the particle. And the minimum radius is 0. Maximum radius, again, is 12. Remember, the biggest particle is 12. And now we're saying, what this line is saying is, if a particle has a radius of 0, it will have no gravity strength. It won't be attracted to it at all. If it has a radius of 12, it has full gravity strength, which is 10 centimeters. So just to make it more obvious, let's just pull that right the way across. So any particle under 6 centimeters shouldn't be attracted to the target. But of course, we've got our constraints which are attracting them. So let's have a look. We'll move that down. Yes, so we're getting the bigger ones being attracted, and it's the constraints that are making the littler ones follow. So now that we've got fewer particles being attracted to this, we could perhaps in the cover one just increase that gravity strength a little bit. Let's pull it up and then pull this up. So now it's the bigger ones that should be attracted to it, and the little ones are following, but that's because the constraints are doing their job and making those smaller particles follow. So that's interesting. That's giving us a little bit more kind of directability in here, and we can obviously adjust that map to get whatever look it is that we want. So that's looking quite nice. Let's put that acuteness of turn down a little bit. So we have lots of control to change the way in which these particles are moving around. Another thing that we could do is we could add a turbulence modifier. Let's bring in a turbulence. Let's bring the size way down, increase the strength. Now this will just make the particles act a bit more kind of erratically, but the constraints are still going to hold them together. So you see they're kind of like moving around on each other. So that can give you a little bit more erratic movement within the ball, but they're still being held together because we've got the cover target and we've got the constraints doing their job. So I'm just going to disable that turbulence for now. So one last thing which would be nice would be if the particles don't just appear on the geometry, but they grow on over time. So how do we do that? Well, we'll do that with a scale modifier. So let's get a modifier, and it's a control modifier. We want to control the particle scale. So let's get scale. And the particle scale is, we don't want them to change over time. We want to set the particle radius, but we don't want to set it over time. We want to set the value. So let's set the value, and we're going to set the top value we want this to be is 12 centimeters. So now it's setting them all as 12 centimeters. That's not quite what we want. So what's happening is the particles are being born, the scale modifier is immediately taken over and making them 12 centimeters. But we want to scale them up to 12 centimeters over time. So the way we do that is we go to mapping. We're going to add a map, and we're going to we want to map the radius value to the age of the particle. So this is saying it's going to take, if it is 0 frames old, it will have 0% of the radius value, which is 12. If it is 90 frames old, that's this not here, it will have 100% of the radius value, which is 12%. So this is going to grow gradually over 90 frames. You can see them growing up until they get up to that point. But we want them to grow up obviously much quicker, don't we? So let's just take that one and reduce that. So we could change the frames amount, or I could just do this, and now they're going to scale up. There we go. Maybe a little bit slower. So we've lost our randomness though, haven't we? When we're using the scale modifier, we haven't got a random value. So how can we add a random value? Well, we can do it with another map. So we want them to, when they get up to full size, have a random amount, right? So to do that, what we need to do is a couple of things. We're going to go into the emitter, into the extended data. We're going to go into the physical data, and we're going to use one of these parameters. Now, it could be temperature, smoke, fuel, fire. It could be any of these. We're not actually using it as temperature or as smoke. We're just using this as a placeholder to hold a number. So if I put 50 in the temperature with a variation of 50, every single particle will have a temperature value of anywhere between 0 and 100. Okay, we're not using this as temperature, it's just a number holder. So now if I go back to my scale and go to mapping and add a map, this is a new map, and we're going to do radius value, and we're going to we'll map to the temperature. And this is saying if a particle has a temperature value of 0, it will have 0 of this 12 centimeter value. If particles have a temperature of 100, it will have 100% of that 0 value. So now, hopefully, it grows up and we have got our random particles back. So this map is growing them up over time. This map is giving them the random values. So now we have random particles growing up over time, and we've got our variation back. So we've got our small ones on the outside and our bigger ones on the inside. Excellent. We could even have them growing up over a longer period. Very nice. So it just makes it look a little bit better, doesn't it? Fantastic. So that is our data mapping. Don't be scared of data mapping. It is hugely, hugely powerful. And now we've got our particles moving towards our target in this kind of nice, kind of erratic way. And of course, we can play around with these with all of the different controls that I've shown you to get whatever look it is that you desire. So I'm just going to go to my constraints. I'm just going to reduce that repulsion so it's only the little ones, increase it so they spit out a bit more, and it's going to make it increase the radius, so that's making them a bit more erratic and flying up on the outside, and that's kind of what I want. So that's looking really, I mean, I really like it as an effect. It works very nicely. Okay, so we can use forces in this way. Let's just see how we might want to render this. So you could render this, obviously, if it's a motion graphics style abstract piece, you can be rendering it as spheres. You can instance whatever objects you want on these spheres to be kind of swarming around this. You could make it kind of creepy crawlies or bees around a honey trap, or whatever it is, you can make these particles. But you could also mesh them and make it some kind of like blobby, horrible liquid. So let's do that one because it's very simple to set up. If we go to generators, let's bring in an OpenVDB mesher. And the OpenVDB mesher says, what object do you want to mesh? Sources, what do you want to mesh? So let's drag in our emitter. So there's our mesh. It's really big and blobby. So for a start, let's increase the voxel size, which reduces the quality. So it's making fewer polygons. It'll run more quickly. And then let's reduce this point radius, which is the radius it sets around each particle. So let's bring that way down to something like, I don't know, something like that. And then in the filters, let's just reduce that a little bit. And then in the filters, let's add some filters to smoothen this out. We'll add a Gaussian, maybe make it even smoother. So what we're getting is a kind of a, we're getting this mesh growing on. And then as we move our target, this blobby liquid, as the particles move and roll around each other, it kind of slops its way in and around our mesh. So that could be really nice for, I don't know, something, as I say, it could be for motion graphics, for a honey going across an object, or glue glooping over it, or some awful kind of alien slime. You've got lots of dynamic control and incredibly fast moving and fast simulating fake fluid simulation here, which is quick and easy to set up. Loads of control of how this looks, and this is all just using our fantastic, the versatile constraints object.